Hey everybody, this week's lab is fairly conceptually difficult, so I thought I'd make a quick video and just talk you guys through some of the things that you are going to be encountering this week. You don't need a lab coat, I was just feeling nostalgic. So it says you need a potato, you need salt, you need the plastic test tubes that came with your lab kits. You will need the scale, which also came with your lab kits. You will need a knife and a cutting board. You also need some kind of marking device. And you can use it. I would recommend probably using a coffee cup. These highly scientific Jägermeister shot glasses will work as well. But if you don't have one of those, a coffee cup will do just great. So let's go through the lab and see what it says. I might wind up updating this, but that's okay. The lab is pretty much going to stay this way. So it says cut 3 slices of potato and record their mass. Each should have approximately the same mass. There should be no skin, and they should weigh about 2 grams. Let me get this back up. So if I go ahead, I like to cut this potatoes into slices that look something like this. So you just have a nice little wedge of potato. And that way it's fairly easy to just clean off any skin and get a nice rectangular potato wedge that looks something like that. And now I can take the mass of this. By the way, I have my scale here, so if I hit that button, and you can use the little lids of these as a weigh boat. I actually probably wouldn't recommend it for you. I would recommend making a little plate or bowl out of like some aluminum foil. That would probably be the way I do it, but this can work. Just make sure it's clean when you're done. Otherwise, you will wreck your scale. So we're going to put these down here, and I'm going to hit the power button, which will tar it or make it go back to 0 to account for the weight of the weigh bowl or whatever you use it for that. So put whatever you're going to measure on there, hit the power button, it'll go back to 0. So this little slice is 1.7 grams, and that's fine. So I'm going to take this, and I'm going to put it into tube number 2. We are leaving tube number 1 empty for right now. I'm also going to record that initial mass on my table here. So 1.7. Okay, let's get another slice here. See how big it is. 2.7, that's a little bit too big. So we'll just go ahead and trim it down a smidge. Be careful, don't cut yourself. 2.0, perfect, excellent. We'll go ahead and record that mass in our table, 2.0. And then we're going to take this and plop it into tube number 2. If I could find tube number 2. I think this is tube number 2. My marking wore off. Beware of that. Okay. Oh wait, this was supposed to go into tube number 3. Haha. Be careful that you don't get these things too big because they can be difficult to get out of this. And that's actually something you're probably going to encounter one way or another. But make sure you get these cleaned out when you're finished with this lab. I'm not threatening you. Make sure you get these cleaned out when you're finished with this lab because these things will start to smell really bad. Okay, let's cut our final 2 pieces. This is for tube number 4. Let's see how big it is. How close did we get? 1.8. That's pretty good. That is for tube number 4. So far we have 1.7, 2.0, and 1.8. And tube number 1 is still empty. And that's for good reason. This gets into tube number 4. Tube number 1, still empty because we are going to use this as a measurement device. And I'll show you what we're going to do with that in just a second here. So let's get our area just a little bit cleaned up. I'm going to move our cutting board and knife off to the side. Got our salt right here that we're going to use in just a second. So what we're going to do is we are going to use our tube number 1 and we are going to fill it with water twice. That is going to give us approximately 16 milliliters of water. Now, if you were doing this in an actual lab, this would not be the way to do this. I would recommend doing it at the sink, by the way, so that you don't spill water in your lab in front of your class. But if you were doing this in an actual lab, I would recommend using a graduated cylinder. This is going to give you a precise measurement. And if you were to do it like this in most labs, you would probably get laughed at, maybe fired, depending on who you work for. Anyway, here is 8 mils of water. That's part of the reason why I spilled a little bit just now. That's not ideal. Let's get our 8 more mils of water here. So now in this container, we have about 16 mils of water, and your instructions say that what you need to do is you need to add a half a gram of salt. So I have my salt here. I'm going to go ahead and just measure out 0.5 grams. It's not a lot. It's a very, very small amount of salt. I'm going to go ahead and put that in here. Stir it up. Make sure that it gets dissolved. Okay, you might need to stir it for a while. You're going to have some extra. This is going into our tube number 2. Make sure there's no more dissolved crystals on the bottom. Okay, and we're going to put this over our coffee cup so we don't spill. And just go ahead and fill it up. There will be extra. Okay, there will be some spillover, and that's okay. Now we're going to take our salt water that we just made, and we're going to pour it into a discard. We do not need that salt water anymore. So tube 2 is now filled with 1 concentration of salt. Let's go ahead and make tube 3's saltwater concentration, or saltwater solution. Okay, carefully, carefully, carefully. 8 mils here. $16 mils there. And to this 16 mils, we are supposed to add 1 gram of salt. Again, that is not a lot of salt. Let's get our salt going on. There we go. We have it. 1 gram of salt will go into our water. Make sure that you are stirring it up. Make sure you don't leave any residue in here. And also make sure that you are stirring this up until all of the salt is dissolved. Okay, this could take a minute or two, and I don't mean like a figurative minute. I mean like this could actually take a little bit to get this all stirred up until it dissolves. Get it all. You might as well model good lab behavior and make sure that this is all getting dissolved for you guys. All right, here we are for tube number 3. Saltwater solution. It doesn't need to go all the way to the top. It just needs to cover all of your potato. So the last solution that we need to make is for tube number 4. I'll go ahead and just measure out our 1.5 grams of salt this time. Okay, there we have it. We have our 1.5 grams of salt. I'm going to go ahead and discard our old salt solution. We will make some new salt solution with, again, 16 mils. 1 test tube. Be a lot more careful than I'm being, please. My results don't actually matter. Your results do actually matter. 2 test tubes full. And for this one, I'm going to just leave it off to the side for right now. I've got 1.5 grams of salt. I'm going to add it to our water here. Make ourselves a nice little solution. It's going to take even longer to stir this one up, but that's okay. Stir, stir, stir. All right, we've got our tube number 4 right here. Again, you don't need to go all the way to the top. That is plenty. And lastly, we have this remaining tube here that we are just going to put water into. So for tube number 1, I get a mass of 2.1, and I'm just going to add our potato slice to that. We'll just go ahead and put pure water all over my lab coat. Okay, make sure you are recording your volumes in this table. And what I want you to do now is go ahead and leave these for 12 to 24 hours. Write down the approximate time that you, or write down when you finish with it. So for me, it's 8 o'clock. I'll go ahead and check these tomorrow morning at 8 o'clock and see if our masses have changed at all. When you check these things tomorrow, make sure that they are dry, by the way. You don't want a whole bunch of just the residual water sticking onto the potato, making it seem like it's heavier than it actually is. Okay, so I think that is all. If you have questions, absolutely, please do reach out. This lab setup is a little bit convoluted. And if you ever find yourself working in a science lab and you find super convoluted lab protocols like this, the reason is because somebody wrote it 100 years ago or 10 years ago or whatever, and they just didn't have the materials that they needed at the time. So they were improvising and figuring things out, and it came out weird. And that's how a lot of lab protocols, strangely enough, are written in smaller labs. So yeah, if you guys have questions, again, shoot me an email. Let me know if this is clear or not. I'll see you guys online.